Hi, my name's Hayden. Welcome back to doing Leetcode every day until I get a job. This is day 7, and we're solving for Leetcode 2140, solving questions with brain power. And we're going to need some for this question. All right, the problem goes as so. We're given a zero index 2D array with questions in them. And questions are tuples where the first index is the points of a question and the second index is the brain power required to solve that question. The problem goes as so. We want to maximize the number of points we get on our exam. However, if we solve, say, this question, because it requires 2 brain power, that means if we solve this one, we can't solve this one or this one. We have to skip the next 2, and then we have the option to solve this one again or skip it. So the whole part of the problem, or the crux of the problem, is deciding for each question whether or not we want to solve for it. Now, the first instinct, or maybe instinct's the wrong word. The first train of thought you should have is I can solve this immediately with recursion, because all this is do I make a decision or do I not? And we can recursively call down and be like, hey, should I make this decision or not? All right, I have to see at this one. And basically, these recursive calls are going to show you the total score if you skip or if you use the question. For our purposes, this is actually an inefficient method. And we can actually solve this with dynamic programming because there's memorization to be had. And I will say that this problem is very similar to Jump Game 2 and Jump Game 1, which is how I developed the intuition, and I knew immediately that this was dynamic programming. All right, so the first thing to do is we're going to create a new array. This is going to be our DP array. This array is going to contain the results if we were to start at the question. So this one contains the result if we were to start at the question at index 3. What's the maximum score we would have? So if we were to start at index 3, it's got 2 points and 5 brain power. If we were to start here, obviously we would want to solve the problem because there's no problems after it. So the maximum score we could achieve is 2. All right, cool. The next thing is if we have 4 and 4, if we were to start here, what's the maximum score we could get? So we're going to compare, the two things we're going to compare are if we solve the problem or if we skip the problem. If we solve the problem, it would give us 4. And we don't solve it, we don't go to another problem because there's no more array. So it's just going to be 4 is the max score we get from solving the problem. If we are to skip it, the way we figure out if the points of skipping it would just be looking at the next index in our dynamic programming array, because this is the maximum total points that we get if we did start there. So that's the maximum total points if we get there. So we're basically comparing 4 versus 2 here, and we're going to take 4. So the whole problem comes down to solve or skip plus 1. Solve or skip dp I plus 1. That's how the problem goes. And if we're to solve this, if we're to continue solving this, what would be the most efficient here? This is going to be 4, can't do anything because not enough places to skip, or 4, so it's just going to be 4. And then we have 3 and 2. If we were to do this, if we were to solve for 3 and 2, this is a little bit different because we get 3 points for solving question 1. But in addition, because we only skip 2 of these problems, we get to solve the third problem. So we actually will then look in the DP array. I guess I should draw it like this. We can look in the DP array at the maximum score we get if we're at index 3. So this would actually be 3 plus 2 because you solve this problem and then you can solve this problem. versus if we just skip it, which is 4. And obviously, this is 5, and that's greater than 4. So we're going to take 5. And then our answer to this problem is just going to be the index at, or the value at index 3. And this is our score. So this is how you solve this, and it's dynamic programming. So if we were to look at the code, it's very simple. We're going to create a new dynamic programming variable. You should usually probably should call this like max score at index, right? And then we're going to iterate backwards through the list as we did it in the Excalidraw. And we're going to destructure our question, and we have to create 2 variables: the points if we skip and the points if we solve. And we have to kind of do some weird conditions with these. So the points if you skip is 0, and then if I plus 1 is less than the length of DP, we're going to use the next one. So this is just to work on the this corner case where we're here and we can't skip. So that's all that all that's doing. So this just accounts for that edge case where I is all the way to the right. And then for the points of solve, we have to instantiate with the points of solving the current problem. And then we have to check to see if we're able to skip, and to see if we're able to skip to this element. So this is this example of solving the first one and then going to the 3rd index or the 4th problem. So if we can skip and it's in the bounds of the dynamic or the DP variable, then we will add the value at that index. And then all we assign to the current index, or the current index's maximum possible points if you get there, is just the max between the points if we skip and the points if we solve. And like I said, we just return the first element, and as you can see, it passes. So that was how to solve LC 2140. And also I would strongly recommend solving Jump Game and Jump Game 2. These 2 problems were actually the reason that I was able to immediately identify this problem as dynamic programming without going down the recursion path. So yeah, thanks for stopping in.